Hey guys, so we're going to be wrapping up Unit 3 now with Chapter 4.8. So we're looking at triangles and coordinate proof. Alright, the key concept here, placing triangles on a coordinate plane, is going to be the steps that you would use when completing a coordinate proof. Okay, so step 1, you want to use your origin as the vertex or center of the triangle. Remember, the origin is going to be 0, 0. So that's right at the center of your graph, okay? And the vertex or the center is either going to be the high point or the, again, center of the triangle, right? Step 2, you would place at least one side of the triangle on an axis, okay? This is going to make it easier for you to work with your numbers, okay? Keep the triangle within the first quadrant. Remember, there are 4 quadrants to your coordinate plane, but we want to work with the first because those are both positive numbers. And then last, we want to use coordinates to make computations as simple as possible. So we're going to use the coordinates to make our job easier. All right, and what that's going to look like. If we're looking at example 1, all right, we're asked to position and label this triangle. So we want to label triangle MNP on the coordinate plane so that leg MN is A units long and leg NP is B units long. All right, we know that since this is a right triangle, okay, and it says right here a right triangle, that we want to have the two sides located on an axis. Okay, so putting both of these legs right here on these axes is going to make our computations a lot easier. Okay, so placing the right angle right here at angle N at the origin allows our two legs, MN and NP, to be on the y-axis and the x-axis. And remember, one of our steps said put the vertex or the center at the origin. Okay, the vertex is right here at angle N. Okay, so positioning our triangle in the first quadrant makes our computations be both positive numbers, right? So remember, when we have a coordinate plane, okay, there are technically 4 quadrants. So we have 1, quadrant 2, quadrant 3, and 4. All right, remember the coordinates, that's the word I'm looking for, the coordinates in our first quadrant are positive, positive, okay? So we have a positive x, positive y, okay? Anything over here to the left is a negative x, positive y, negative, negative, and then positive, negative, okay? So seeing how both of our numbers are positive in this first quadrant, that's why we want to work with that, because it's a lot easier and more efficient to work with positive numbers than a bunch of negatives, right? So since we have M here on the y-axis, okay, so M is here on the y, our x-coordinate is 0, okay, because remember, anytime you have something along the y-axis, your x-coordinate is 0. We have our y-coordinate as A because, again, we wanted to have our unit as A units long, or this side is A units long, right? So we don't know how long this is, but having it A units long, we could say, okay, well, this is 1, 2, 3, 4, or if it was shorter, we could say 1, 2, 3. Being A units, we could change it to whatever number we need, okay? So this is our x, comma, y. X is 0, y is A values, okay? And then also, since P right here is on the x-axis, then our y-coordinate is 0, okay? So again, anything along the x-axis has a y-coordinate of 0, okay? We were asked to have leg NP as B units long, so that's why our x value is B, okay? Because again, we don't know what B is, we don't know how many units B is, but having it labeled as B allows us to count like so. So we have 1, 2, 3, 4, 5. We could say P is at 5, 0, okay? Just for an example. Now moving forward to this other example, we want to identify any missing coordinates. Okay, so we're asked to name the missing coordinates of our isosceles triangle XYZ. Okay, remember isosceles triangles have two congruent sides, and then we have X, Y, Z right here, right? So we have vertex X, so this angle corner right here, X, positioned at the origin. Remember, we were asked always to put our triangles either with a vertex on the origin or the very middle at the origin. Okay, so X right here, being at the origin, is going to be 0, 0. Because remember, origin is 0, 0. Looking at vertex Z, we have it as A units long. Okay, so just like we did before, we don't know how long it is, but we are going to make it A units. Okay, since it's along the x-axis, our y coordinate has to be 0. Okay, so A, 0. We don't know what A is, but we do know that y is 0 along the x-axis. Okay, and then our last thing to decipher or figure out is what is our y value. Okay, so we know that y is going to be halfway between x and z. Okay, and why do we know that? If we were to draw a vertical segment, okay, or a little invisible dotted line right down the middle, okay, so I apparently can't draw straight lines. All right, so y falls right here in between x and z, okay? So our vertical segment, and then remember the hypotenuse leg theorem, that's going to say, okay, y is somewhere halfway between x and z. Well, it's hard to determine the value of x because our z value is a. But we can say that since z is a and y is halfway, we can say that the x value is a over 2, or, oops, halfway between a, okay? For our y value, or how high it is in relation to our y-axis, we don't know that, okay? We don't know the number, but we know that a is already claimed for our x-axis. So for our y value, we can say that it is labeled in terms of b. So if I was to say, okay, this triangle is a units long, 3, 4, 5, so a long, and then however many b high. So this means that our specific triangle is a over 2 units, comma, b units. Alrighty, and then our last example, we are going to be classifying a triangle based on information given. So the Bermuda Triangle is a region formed by Miami, Florida, San Juan, Puerto Rico, and Bermuda. Okay, so different areas of the Caribbean area. Okay, so the approximate coordinates of each location respectively are given. So this first one right here, we will color that pink. So this is the location of Miami, right? This coordinate location is San Juan, and this coordinate location is going to be Bermuda. Okay, we want to write a coordinate proof to prove that the Bermuda Triangle is scalene. Okay, that's going to be our important word here, scalene. Remember, scalene has no congruent sides. Okay, so that means that if the Bermuda Triangle is in fact scalene, each distance will be a different value. Okay, so first I want to start off by labeling my triangle with the given points. So I'm going to put Puerto Rico down here at 1848. Miami, I want to put right here. And then last, Bermuda is right up here. Comma. All right, so the reason I put these in the order I did, notice our x, if we were to call these x values, right here, this is in degrees north. So if we were to think about what we did earlier, we didn't necessarily have x and y. We called it A units, B units. This is the same concept. So our first value is in degrees north, right? So degrees north, degrees north, degrees north. Next is degrees west. So if we're looking at our north degrees, we have 18, 25, 33, okay? So they're getting higher as they go north, right? And then our west values, 66, 80, 64. So if we went in order, 64, 66, 80. So the farther west we go, the higher the number gets, right? This is the reason that we're doing these coordinate proofs, okay? It gives you another way to look at coordinates, or your x's and y's, in different terms. Okay, so we're asked to prove that the Bermuda Triangle, so this whole triangle right here, is scaling, okay? In order to solve that, remember, to find the distance from one point to another, or the length of the side, we need to use our distance formula. Okay, so remember that is the square root of this plus your difference in y's squared. Okay, so to determine the side of the length of each side of my triangle, I need to plug in my coordinates. Okay, so I'm going to start with Bermuda. Okay, so the distance of, and I'll do colors for the given points. Okay, so I'll use Bermuda as my x2. So we have minus squared. And then we're going to use our y2s now, in this case degrees north, so 64.68 minus, oops, we're getting squished here. Here, let's scoot this over first. A little bit. There we go. Okay, and then we want to subtract Puerto Rico's right there. So we're going to plug this in and determine the distance from Bermuda to Puerto Rico.